What?
I was asking this from Jake.
Why did Jake show up with the second one?
Yeah, he showed for like the second review.
That's the one I wanted to come to too.
Don't worry.
They shouldn't have put kinematics and meta-optics.
No, don't worry. We
I
got
can watch that later. Can you put it on YouTube?
Yes. Is it okay? Or maybe I could put it on the teacher tube.
Well, I can't get on Teacher Tube.
Why not?
I thought students couldn't get on Teacher Tube.
There's no login. It's just pathetically slow on downloads.
YouTube's faster.
Okay.
But you can't access it at school.
Well, I could bring it to
Not
school and just
legally.
upload it on. And Freddie Rigo knows a way to bypass the security.
I don't want to know.
I'd like to know. I can't find it.
My own son knows how, but he never told me because I wouldn't let him.
Okay.
Proxies don't work anymore.
Huh?
Proxies don't work
They're
anymore.
blocking the German ones.
German?
Yes, the German ones. I actually find all the proxies in the world. They block the German ones, the Chinese ones, the Russian ones, the whatever.
The German ones are the funniest.
Wiener Schnitzel proxy. Yeah, that was on Jeopardy the other night. That was hilarious. It said man and Schnitzel and Wiener Schnitzel. It just sounded funny when Osterbeck said it.
Alright. Let's see, what else can we get into in kinetics that's not going to take forever in a day? Because this is the time of day everybody starts getting really tired.
I usually have my nap.
Alright, look at problem 1990.
Way before
It's
that.
on page 3 of the kinetics problem, the kinetics questions that I gave you.
You ever heard of chronological order?
Wait, this goes to 5.
I'm just providing enough information to keep you all busy. One of the first rules in teaching, have too much to do. Right? Right, alright. Problem 90. This is from questions 5 or 6 at the end of the exam. It's the last things you're going to deal with, and it's probably not something that you're going to put a whole lot of effort into. Okay, just be brutally honest. They're worth either 8 or 9 points each, depending on how many things are going on here. 1, 2, 3, 4, 5, 6, 7, 8. This one's worth 8 points. Okay? 4 parts, 8 points. To me, that's a bargain. It gives you some information at the top. It says A plus B yields C plus D, and then it gives you enthalpy change at negative 10 kilojoules. So automatically start thinking it's exothermic. So that means heat is going to be written as a product. So keep that in mind as you start going through this. It may help you understand some other aspects of the problem. Describe the two factors that determine whether a collision between molecules A and B results in a reaction. Okay, so what are two characteristics or two factors that determine whether or not a reaction actually takes place?
The amount of energy and the orientation.
The orientation. So you would just need to expand upon those. Molecules have to collide with each other with sufficient energy. They also have to collide with each other in the right orientation. Just because you smack into something doesn't mean you're going to bond with it. Okay? And so that's 1 point for each one of those factors. So this is not, can you elaborate on the kinetic molecular theory? This is just, can you remember two factors and provide some sort of reference point?
What kind of reference point?
You have to have, number one, you should say kinetic energy. You have to have a minimum, I would just say, you have to have a minimum amount of kinetic energy for the collision in order for a reaction to occur. The molecules must also be at the right orientation for bonding to occur. Clyde, what are you doing? Do you? Shouldn't ask it that way. I know you play with the faucets in my room, but do I like it when you play with the faucets in my room?
I haven't done that recently.
I didn't ask you if you'd done it recently. I'll leave that to Jake and CJ. Part B.
We've never done anything in your room that we haven't done in the Eastern room, except for the time we hit the ceiling with water.
And you shorted out all the batteries.
2 of them. Well,
Hey, let's see what happens if you put them all together.
I flipped 2 of them, and it started smoking and about caught on fire.
Yeah.
Pulled it apart with my bearing. It was power.
Part B. How would a decrease in temperature affect the rate of the reaction above? And explain your answer.
Slower reaction.
Decrease in temperature is going to slow the rate. Why?
Because
Higher energy, higher
the
temperature.
lower energy, the amount
Use the
of
word
energy-
collision somewhere.
the amount of collision would
Increased collision
decrease because
for-
of the lower energy for it.
Very good. Okay. Lower temperature means lower average kinetic energy, right? Because isn't that the definition of temperature?
Yeah.
So if you reduce the average kinetic energy, your molecules are going to be moving at a slower rate, and so you're going to have fewer collisions. Try to use the appropriate terminology. Even if the argument is right, try to put in the right words. Okay?
So
And it-
like, whoa, for reactions in which two molecules or elements are combining, the higher the temperature, the faster it'll go, and the slower the temperature, the
Generally
lower.
speaking, yes. There are exceptions to every rule, but that is a good argument. Okay? That you heat them up, they speed up. Okay, part C. Write the rate law expression that would result if the reaction proceeded by the mechanism shown below. So it's telling you what the mechanism is. Write the rate law.
Would it be like KAV squared?
That's what I got.
Yep. Because you go through the fast, you go through and including the slow step. So once you reach the slow step, you stop looking, because that's going to, where the slow step is determining how fast the reaction is going. Okay.
I swear that thing.
The best thing that's happened today was, man teaching physics, they had a giant eraser, smartboard eraser thing, and there was stuff written on the board, and he picked that up and he went, oh yeah, this is a man's eraser, and he went to erase and it didn't erase anything. It was like useless, like even if you spray that stuff on there, it wouldn't do it. And Miss Ethan just laughed and went, yeah, it's a man's eraser, it doesn't work. It was hilarious.
That is pretty funny. All right, part D. Oh, you got 2 points for part C. You basically got 1 point for each response in A, each response, the answer plus the justification in B, and then C you got 2, just straight up. So if you got that wrong, you missed both points. There's no, yeah, that's it. That's the way it is sometimes. And then in D, explain why catalyst increases the rate of reaction but does not change the value of the equilibrium constant.
It lowers the activation energy and is not directly involved with the reaction itself.
Okay. Basically, lowering the activation energy is going to...
Tell her about the man's eraser thing.
What? Oh, it was so good. You listen. He picked up his huge eraser and he said, oh, it was just perfect since I'm the only female in the room. He said, this is a man's eraser. He said, of course, it wasn't an eraser and it didn't work. I said, yeah, it is. Doesn't work.
Did the students appreciate that?
Oh, they thought, I mean, you knew I loved it.
I thought it was hilarious. He was just like, oh. Just the disappointment in his voice when he stopped.
It shows
They're doing a kinetic energy conversion problem, and I had to leave the room because I'm so tempted to tell them what they're missing.
What is it now?
They don't realize that they have to subtract the beginning velocity and the end velocity. They're trying to see.
Go ahead.
The friction made it slow down. The friction didn't make it stop. So they needed to take the initial velocity and the final velocity and take the difference. But they're doing the problem, the whole thing, like it's coming to a stop. So I had to leave. I just looked at him and said, I have to leave. Because he won't let me, Jeff won't let me say, because I want to say, what did the word friction? Did it make it stop? He won't let me leave them as much as I want to leave them. And I've told him the reason I want to leave them is number one, they can't get along and fuss all the time. Number two, we only have 50 minutes and we can't get the lab done before the bell rings. So I don't feel like I can, I feel like I have to say, okay, come on, we're going to do this.
A majority of us get along.
Okay.
The 3 out of 6.
That's half.
Four out of six.
If half of
I
the
was gonna say
people,
that's not a majority, CJ, it's 50.
Four out of six.
I've got to leave.
All right, so basically what CJ said a second ago, the equilibrium constant is not affected because it's not going to affect the energies or the concentrations of the reactants or the products, which is what equilibrium is based on, right?
Right.
So you have to mention reactants and products somewhere in there because that's what the equilibrium part of that question is getting at. Okay? So lower the activation energy, thus increasing the rate of the reaction by providing an alternate pathway, if you will, but that's not probably necessary. If you say lowering the activation energy and increasing the rate, and then the second part of that is it does not affect the concentration or the energy of the reactants and the products, which is what equilibrium is based on. Okay, and that's 2 points, one for each one of those concepts. So to me, this is a pretty easy problem. But a lot of times, questions 5 and 6 get skimmed over because you're tired. It's 3 hours and you're done and you don't want to think anymore and you look at this problem and you're like, oh my goodness. But at least
Did
it's
you guys
tempting.
go into it first or just?
If you're fairly confident in your net ionic, because you won't get to questions 4, 5, and 6 until your calculator's pulled away from you. So if you're fairly confident in question number 4 that you're net ionic, go to questions 5 and 6 first, and then come back to the thing that you feel the most comfortable with. But don't spend a lot of time writing heavy sentences. This is not biology. Biology is all about writing sentences and explaining and using as much terminology as possible. Here, it's all about getting to the point, but using the right terminology. So use the word collision, use the word activation, and so forth.
Yeah, no, biology, I looked at the exam and it's like, it was so above my class. Well, like, my school, they're crazy. Like, in our biology class, they teach us creationism. So it's a bit jump from that to, you know, an actual, you know, science.
Evolution.
Yeah.
We're getting into the evolution part of it, just when you break down all the different phyla, that was.
You can turn that off now. I mean, we're effective.